So we are been working with trig ratios. I noticed that some of you have struggled a lot with solving using trig functions. So this video will guide you through some of the examples to show you how to solve using the sine, cosine, and tangent function. So let's just quickly review about the trig functions. Notice that if we have a right triangle with a given data or a given angle, we can label the sides of the triangle according to the data. The side opposite of the data is called the opposite. The side right next to the data, it's called the adjacent. And the side opposite of the right angle is called the hypotenuse. Our trig ratios can be defined by written ratios according to the sides. Sine of data, for example, is defined as the opposite over the hypotenuse. Cosine of data is defined as the adjacent over the hypotenuse. And tangent of data is defined as the opposite over the adjacent. Here, I provided 4 steps for solving trig functions. Our first step is to always label the sides of our triangle depending on our data. So that is to go ahead and label O for opposite, A for adjacent, and H for hypotenuse. Our next step is to pick a function. So we will pick the function sine or cosine or tangent. Then we have number 3 is to write our equation. And last is to solve the equation to find the unknown. Let's go ahead and work through this example. Say we have a right triangle with a data of 52 degrees. Our first step is to go ahead and label our triangle. Notice that the side opposite of 52 is x, so this will be opposite. Then the side right across from the right angle is 10, so that would be our hypotenuse. And our side right next to it is the adjacent, which is not labeled in this triangle. But let's go ahead and make sure we write down what this is. Notice that we have the opposite labeled and the hypotenuse labeled. So we will be using the sine function. Let's go ahead and begin. We will say sine of 52 degrees is equal to the opposite, which is your x, over your hypotenuse, which is your 10. In order to solve for x, we will go ahead and multiply both sides by 10. On the left-hand side, you will have 10 times the sine of 52 equal 10. We'll cross that out, and we will have x. This is a number which can be found by plugging it into your calculator, so I'm not too worried about showing you how to do that. As long as you can get to this step, you should be fine. Let's go ahead and continue to example 2 now. And this time, I will give you some time to work on this. In example 2 here, your job is to go ahead and label the side as our first step. Remember, we are working with this angle, 66 degrees. Let's go ahead and label it now. You know that the side opposite of 66 is y, so we will label y as your opposite. And you know that the side right next to 66 is 11, so we will label it as your adjacent. The side right across from the 90-degree angle is your hypotenuse, and it's not labeled in this triangle, but we'll still write it down. What trig function can you now use knowing that you have the opposite and the adjacent? Go ahead and take a look at your notes. Correct. We will be using the tangent function. Let's go ahead and make sure it's black So tangent of 66 degrees equals the opposite, which is your y, over your adjacent, which is your 11. In order to solve for y again, we will go ahead and multiply both sides by 11 so that we have 11 times tangent of 66 equals, those will cross out, and you'll have y. Again, this answer is practically correct, unless you want to go ahead and use your calculator to find out the length of y in a decimal form. So how about if you're missing an angle rather than a side? Well, we will follow the same steps, but this time we will apply the inverse functions. Do you guys remember the inverse functions? Let's go ahead and review. The inverse functions are, for sine is the arc sine, or we also say sine to the -1. For cosine is arc cosine, or we can also say cosine inverse, which is cosine to the -1. Similar for tangent is arc tangent, its inverse function, or we can also write tangent to the -1 as the inverse tangent. Example 3, I will guide you through it just like I did in example 1. Notice that we just have a data this time, and we will be using the inverse functions to compute what data equals. The side opposite of data is CB, which is not labeled for us, but we'll still write the O for opposite. The side adjacent to it is 11, so let's go ahead and label a 11 as the adjacent. And the side right across from the right angle is 14, so that will be our hypotenuse. The function that we will be using involves the adjacent side and the hypotenuse. That will be your cosine. So you will write cosine of data equals 11 as the adjacent over 14, your hypotenuse. In order to solve for data, we will go ahead and apply the inverse, and we'll use this notation. So you have cosine inverse of cosine theta is equal to cosine inverse of 11 over 14. Notice that the cosine and cosine inverse kind of undo each other, and we will have theta is equal to the cosine inverse of 11 over 14. This again is something you can just plug in your calculator, and you will be able to obtain the degrees for the value of theta. This time, let's go ahead and take some time to label the sides. Notice the data is right here. The side opposite of data will be this one right here. This side right next to data is 8, so let's go ahead and label it adjacent. And the side across from the right angle is 9, so we will call it the hypotenuse. What trig function should we use? I think this is very obvious, and we worked through it a little bit. Yes, correct. We will use the cosine of data to say that is the adjacent, that is 8 over 9. This time again, because we are looking for the data, we will apply the inverse using this notation. And we also have cosine inverse of cosine data is equal to cosine inverse of 8 over 9. Okay, notice that this undo each other, so you're left with data equals the cosine inverse of 8 over 9, which can also be plugged into your calculator. I hope that these examples provided to you will help you. Make sure though that you do not carry this misconception. The sine inverse of a ratio is not the same thing as 1 over sine of x. That negative 1 does not act upon as an exponent. Again, neither does this. For example, the cosine of some ratio is not equal to 1 over the cosine of x. And similarly, the tangent of some ratio inverse is not equal to 1 over the tangent of x. I hope that helped you. Have an awesome time.